Hi, I'm David Thompson. I'm the director of Milaco Engineering. We specialise in DSEAR compliance. I'm going to talk today about how DSEAR affects distilleries and how by putting simple procedures in place and policies, you can use it to your advantage in the future. So what we're going to go through today is an introduction about DSEAR, what it is, and what we hear a lot when we go on these sites. We're going to talk about a DSEAR company policy and why this is the biggest piece in the puzzle. And then we're going to talk about normalization of deviations and look at incidents in other industries and what we can learn from them. So, the Dangerous Substances and Explosive Atmospheres Regulation came into effect on December 9th, 2002. It brought into effect two European directives, that's the CAD Directive and the Explosive Atmosphere Directive 137. It's concerned with the risk of fire and explosion from dangerous substances at the workplace. From 2005, it also covers gases under pressure and substances corrosive to metal, but we're not really going to talk about the bottom two. We're just going to stick with ethanol. So this is what we hear a lot when we go on sites. It doesn't apply to us. It applies to all sites using or handling flammable materials, i.e. ethanol. We have never had a fire and explosion. This is not just in this industry, but in other industries, it's a big cause of incidents. And we need it for insurance purposes. Ideally, you need it for safety, first and foremost. The insurance companies are asking for a risk assessment, which then they'll use against you if you're not putting the recommendations from that risk assessment in place, for instance, i.e. inspections of electrical equipment. They'll use that against you if something happens. So why are we talking about a DSEAR policy? And why do we think it's so good? It sets the standards of behaviour, conduct and performance for employees and management. It helps companies meet the obligations of regulations and laws. And it also can help your process grow safely and meet the demands of your business. So first and foremost, you need a DSEAR risk assessment, where the hazard is the flammable substance or the properties of that flammable substance, and the risk is of an ignition source being introduced that would lead to one of the following. If you miss out the top one, believe, I would concentrate on the bottom four. You should have a current risk assessment in place, and it should be periodically reviewed every 3 years, unless there's a significant change in your process or if there's a significant change in your staff. Also, if you swap out a substance for another dangerous substance, or a dangerous substance is brought onto site. So how do we reduce the risks? To ALARP, we reduce the risks using the controls put in place by DSEAR. Elimination wouldn't be one that's used in this industry. It's usually where you'd swap out a highly flammable substance for a less flammable or non-flammable substance, which would, if I give you an example, cleaning products. So you could reduce the amount of finished product that you're storing in your production area. However, the main ones that you're going to be using is engineering controls, administrative controls and mitigation. The engineering controls, you're going to use ventilation and pipe work to limit the amount of releases that you've got around your site. You can also use electrical controls and mechanical controls to do that. You've got administrative controls, safe systems of work and procedures, limit interaction that your staff have with these flammable substances. And mitigation, what happens, what do you use if something does happen? You can use pressure relief, explosion relief, bunding to contain large spills. The building construction, i.e. if your building is made out of concrete, it's a lot less reactive to fire than a wooden building. So can you do a risk assessment yourself? If you can see the risks from the substance you're using Ideally, I recommend it for small micro distilleries. There's enough information out there, and there's the approved code of practice that the HSE have written for your guidance, which I think go from L135 to 139, which is good information. However, for mass-produced stills, a lot of the time, this can be part of the manufacturer's instructions. I don't always see it when I go onto sites, but some sites do get it. I think it's something you've got to ask for as and when you pay for it, and this is an example of that kind of information. This comes from a Muller still, a compact 3. Again, for your large bespoke distilleries that you're getting designed, this should be part of your design package. It should be part of, you should be getting a hazard study and your DSEAR risk assessment, and them combined should be starting to make your safe working procedures. If you just notice on the right-hand side at the bottom, the manufacturers are asking you for regular air changes in the distillery. And this is because some of the equipment they use on these stills are not always certified for hazardous areas. So you have to be aware of what they're asking you to do, because this is often missed when we go around sites. So the next part of your policy is your hazardous area classification. After you've reduced all the releases to a minimum using pipework and ventilation, the remaining areas should be classified into zones, and an area classification report, and ideally, should be combined with area classification drawings. Each release will be allocated a zone, a T-class, and a gas group. The gas group and the T-class will stay the same. The gas group for ethanol is 2B, the T rating is T2. However, the zone will alter. When we look at zones, we look at a zone 0, an area where explosive gas atmosphere is present continuously. You're looking at the internals of storage vessels, you're looking at the internals of stills. Zone 1, an area in which an explosive gas atmosphere is likely to occur. I'm looking at open vents, the likes of spirit safes. And then for a zone 2, an area in which explosive gas atmosphere is not likely to occur, you're looking more along the lines of flanges which shouldn't leak, but over a process of or period of time could, pumps and pressure relief valves that are not supposed to be working in normal operation. So this is just another example of the information that you can get off the manufacturer. And if you see, they've allocated certain zones. I wouldn't necessarily agree with all them zones, however, it's perfectly okay to use this, as it says it in a couple of the standards. And across from that, it gives the zone allocation and the reason for these allocations. Here's an example of an AC drawing, an area classification drawing. This is both plan and elevation. And all I can say with these is a picture paints 1,000 words. It's very hard to try and distinguish where these zones are for people. And it's a lot easier if there's something like this at the workplace. So the next part of the policy, you need to be looking at your ignition sources inside these zones. At a minimum, you should be looking at these 4. Chemical, you shouldn't be storing incompatible chemicals together. However, you should have already covered this with your cost assessment. So the top 3, heating, electrical and mechanical. If you can remove and exclude, if possible, from these zones, great. If you can't, and you do need them for the processing, you start having a look down the area, the ATEX certified equivalent. And then just under electrical and mechanical, you need to look at the potential of static. This can come from, so you need to make sure everything's at the same potential. You might get transfer. You might be transferring ethanol, and it could be through a plastic pipe. You need to make sure that both bits of kit are at the same potential. So ATEX certified equipment. ATEX equipment is designed and certified to be used in potentially explosive atmospheres. Ideally, you need to be having an initial inspection on these pieces of electrical equipment before they're brought into service, to prove that the protection concept is safe. And then periodically, every 3 years, you need to be getting these re-inspected to maintain that the protection concept is still safe. Mobile equipment, you should really be inspecting it yearly and every time you use it. And ideally, and this is the most important one I think, is the inspection activity should be sufficiently independent of the installation and maintenance team. And the reason for this is on the next slide. Now that's an EXD light fitting, which should be able to contain an ignition inside it if the flammable atmosphere was surrounding that light. However, due to the glands that were used during the installation, the protection concept is likely to fail. Now, this got missed due to the fact that the team that installed it were also the team that inspected the equipment. And from that, so the light fittings are not cheap, and every light on that site failed. Again, we was brought into a company to do an initial inspection before handover from the contractor. So they brought us in to just do an initial check, which they get the work done before it was handed over. If you look on the left-hand side, nothing really looks out of place, but then what had happened is they'd sheared one of the bolts off on the motor, and to hide the mistake, they'd put a conductor over the top so it looked like it was still connected. Now, if you're not getting initial inspections done on your equipment, you're going to miss these things, and you don't always pick these up. So in the last two, we're just going to look at arrangements for accidents, incidents, and emergencies, and information and training. So you need to know what to do in an emergency, and the faster you can efficiently act, the more chance you have of protecting people and your distillery. And the other thing is, really, you need to know where people are. You don't want to be sending the fire brigade into a burning building looking for someone that the only reason you don't know where they are is because they've gone out another exit and they didn't know where to go. You also need to provide some kind of information for these people because they're going into a building and they don't know what's in it. They could ideally need to know the amount of flammable substance in that room, or if there is any flammable substance in that room. And finally, if we just look at training and how it helps improve the knowledge and skills of your employees. It helps them identify potential hazards. It helps to prevent accidents and injuries, and it promotes the right culture, and that's the main thing. It promotes the right culture. It's very hard to change a company's culture when they've been doing something for so long. So this is normalized deviations, and there's two pictures here on two separate sites that we went to, and on the right-hand side, there's a kettle and boiling on top of a drum of ethanol. Now, so everybody sort of knows that's wrong, and the guy who owned this site knew that was wrong, but over time, he just got comfortable with what he was working with. Nothing had happened when he did it. And then when I asked another member of staff why they do that, he said, well, because the boss does. And this is what I mean, you're breeding a culture that is effectively, eventually something will happen there. This one on the left-hand side is a little bit different because on handover, they didn't get the area of classification. And this is what I mean by having a policy in place, you can ask for these things. They didn't have an area of classification in place, and the vent just above the door there is an external vent for the ethanol tank. And also, they didn't provide a smoking area for the staff, and they also didn't tell them that they couldn't smoke on site. So smokers do what smokers do, and they find a place to smoke, and they were smoking at the tables. Again, nothing was happening, but eventually something could happen. And now we're just going to look at two incidents where we've talked about where maybe a policy could, or maybe lacking in policy, could have helped. So this was Buncefield. A low-lying cloud of heavy flammable vapour accumulated and spread over 250 metres in all directions. And the tank released 250 litres of fuel. So this was picked up by truck drivers on site. It wasn't picked up by any safety systems or anything. So the conclusions of this report, the process safety controls of the safety critical operations were not maintained to high standards. Both the high-level switch, so they had a high-level switch and they had an independent high-level switch which should have shut the system down. The first high-level switch went faulty, and the independent high-level switch, which was installed 6 months prior to this, wasn't installed correctly and wasn't inspected before being put in use. So neither of the high-level switches operated. So again, senior managers did not apply effective control, so you could look at it and say that the companies did not set the standards for their management team. Effective auditing and monitoring systems were not in place, like we just talked about. There was no inspections done initially or periodically to make sure that this equipment was safe to use. And the high level of confidence, which you find a lot and which we looked at in the previous 2 slides, that they completely understood the flammable risks were not justified. Such attitudes are always dangerous. They'd normalised a lot of deviations on this site, and it ended up costing them. And I think the cost of that, it was the biggest disaster since the war, and I think the cost run up to in the region of 800 and something million. So now, I just thought I'd put in a recent one, just to show you that it still happens. This was one in Halifax, and a worker had been decanting heptane from a metal drum into a plastic bulk container. The splash filling of heptane generated a static charge and created a spark, which caused an explosion during the decanting process. Flammable material then spread. The flash point of heptane is -4, so it's always giving off vapor, and the auto-ignition temperature is 220. So when we look at the conclusions of this, it was an unsafe process of decanting, despite well-known industry guidance. So again, there was no setting of standards for the behaviour, the conduct, and the performance of these people on site. The uncontrolled spread of fire due to lacking containment. IBCs are used a lot in your industry. They're great for storing ethanol, but in a fire, they're useless. Within 5 or 10 minutes, whatever's in that IBC will empty all over wherever it is, basically. So you need to start looking at other ways to contain that if that does happen. And a poor practice of storing cardboard nearby allowed the fire to spread significantly. Again, this is just general housekeeping. You shouldn't really be storing flammables close to where you've got dangerous substances, and a lack of training and supervision, which we've already talked about. But one last point on this site, the director was fined and taken to court. However, he knew nothing about what was going on site, and because he'd not set the standard of if a flammable comes on site, you need to risk assess it. So what had happened is the people on site had come up with their own process, and it wasn't exactly the safest process. And that's that. So I'll open the room to any questions. Well done well there. Thank you.